This conference will
So,
now be recorded.
I am Amrit Lal from third year BE Mechanical Engineering student. I am leader of JODHPUR Solidworks user group. I'm a Solidworks champion member, and these are my some certifications which I have. My area of interest lies in automobile and CAD designing. So basically, what is JODHPUR Solidworks user group? Network and what we do. Our mission. The mission of SolidWorks user group is to empower real people who use SolidWorks products to collaborate with, learn from, and teach us. Connect with us anytime, anywhere, on any device for an in-depth technical conversation and face-to-face networking. We will see you there. We can discuss anytime regarding SolidWorks. You can call me, like if you have any problem, you can call me anytime. I will help you out for the same. Okay. Slogan is everywhere. Basically, we have 182 groups worldwide. We have 9K plus members. Thousands of events we organize every year, and we provide free training to all of you. About the speaker, today's speaker is Dan Wagner, sir. He is manager of SolidWorks User Group Network at Dassault System. He joined Dassault System at September 2020, and he is working with Dassault System currently. Before that, he worked as a support engineer manager at Computer Aided Technology from July 2008 to September 2020. He done his Bachelor of Engineering from Temple University in 2004 to 2008. Okay. Thank you for listening. Now, session is over to you, Dan.
Great. Thanks, Aaron. I appreciate it. I want to get maybe a quick check of our audience today and just kind of check in with everybody. I'll show my screen here. Let's see some, I guess, level of experience with SolidWorks. So let's get some answers in the chat here. Have you been using SolidWorks for a couple years? Do you have a certification? Are you using it in school? Like let's hear it in the chat. Let's understand who's joining us here today, because it certainly helps us, when we do presentations like this, it helps tailor the content, and it helps us understand again who we're presenting to. So you should see a chat in GoToMeeting, where feel free. The chat is like the hangout of this meeting, and I think these meetings, you always want them to feel fun and casual, and feel free to throw some answers or throw some information in the chat. We see one person said, been using SolidWorks for 2 years now. Awesome, that's really great, that's cool. Getting some other answers here. CSWP, 2 advanced certifications. Amrit, yeah, you're crushing it, right, with certifications. Amrit, what did you think about some of those advanced, like that? Did you say you took the Weldment certification? What did you think about that one? Oh, you're muted, I think, still too as well.
So I have basically CSW for mechanical design and advanced certification of sheet metal and surfacing.
Sheet metal and surfacing. Surfacing, what did you think about surfacing? Because I thought that was pretty tough. I took that also.
Yeah, it is very tough. Like I have attempted for 2 times and I got cleared it in second time.
Okay. Yeah, same here. I failed. I took it once, didn't pass it, I had to take it again. Because surfacing, yeah, is like it's a whole other thing. So that's cool. I agree. Anybody out there, if you're looking for certification information or any certification help, we can help you get started down that SolidWorks certification path. But yeah, that surfacing one is something else. That's a tough one. Okay, so I'll keep an eye on the chat here during this presentation. So if you have questions, if you just want to throw out some information, again, use the chat. Feel free to interrupt me. No worries at all. This presentation is meant to be a solid, as Amrit advertised it, a SolidWorks for beginners, or just kind of getting started with what SolidWorks is and kind of understanding the interface. But if there's anything you want more information on, or any topic you want me to dive a little bit deeper into, we can also do that as well. This is, again, totally informal and more than happy to do it. And Amrit, thanks for the introduction as well. That was very kind. Thank you. So I have SolidWorks 2021 installed locally, and there's a few different installs or a few different versions of SolidWorks you can run these days. I'm showing you on my screen here SolidWorks 2021, the local desktop version. We also have a version of SolidWorks that connects to our 3D Experience platform, so you can save your files directly to the cloud. That's an option. There's also versions of the CAD tools or the design tools that live on the 3D Experience platform. So those tools you can actually design in 3D on the platform. So it's very different. So I'm kind of just explaining or drawing out some of the differences of what we're seeing here today. But the 3D Experience platform is pretty interesting. We're not really getting into that today, but I'm just showing you what the platform looks like because I think it's important to know these things. If you ever get to the point where you're wondering, does SolidWorks have a cloud-based solution or a browser-based design solution? Yes, we certainly do. We have XDesign and XShape and other design tools that are based entirely in the browser. Today, I'm going to be, again, focusing more on SolidWorks desktop, but these things are important to know. This is a boat that I designed with my son. I have a 5-year-old, so we designed this cool boat, and then we 3D printed it, right? We actually 3D printed it, and it works pretty well. So you can do. So Amrit, you said you took the surfacing exam. This would be tough to model in SolidWorks. It would just take you a while, right? It's a curvy model. It would take you a little while to do it. Whereas on the platform, you can do this in a matter of minutes, which is pretty crazy.
Yeah, it is so easy to do it in 3D sculpture model.
Exactly.
I have tried that.
Yeah, it's a lot easier. So important to know. But again, today we're focusing here. We're on the desktop version of SolidWorks, the version that I have been using for probably the better part of 15 years, a long time. And again, I think a lot of people started here. A lot of people, this is where you build your knowledge base and then you can expand into other areas. So Hemant is asking in the chat, how do we download SolidWorks software? So if you're a student at a school, your school should be able to get you access to it. If they have a license, of SolidWorks, they should be able to give you a download. If you own SolidWorks software, if you actually own a license through a company or own it yourself, you can go onto your customer portal on solidworks.com. I'll open up a browser here real quick, and you can download from there. So that's solidworks.com. And then on solidworks.com, you can log in to your customer portal. And in the customer portal, you can download SolidWorks directly from there. You can do that as well. Okay. So in 2021, SolidWorks Desktop, this is an assembly. So this is what we call an assembly or a group of parts. And those parts are individual standalone part files. So for example, if I were to open up this guard by itself, right? I pick this guard and then I hit this little open part button. This part exists on its own. It is a individually created item that was modeled by somebody. And then when you put those parts together, you get assemblies. This is an assembly. So if you're new to SolidWorks, the whole idea, right? The whole point is to model parts in 3D, put them together and see if they fit and see if there's clearance issues and model parts based upon other parts. That's how you create assemblies in SolidWorks. And you also want to test motion. So because this is an assembly, I can put this together and test motion, test how this movement works together. These are all things that we can do with SolidWorks once we are in 3D. So just kind of a brief overview of the interface, because I'll jump around the interface and I'll use some different terms as we go, and I just want to make sure that you understand the terms that we're using here. So the first term we'll say is the part tree. Mostly everybody will call this area the tree, and this is basically your recipe or your list for how this assembly was built. So the tree will list out all the individual parts and the individual sub-assemblies within those higher level assemblies. So this is the tree, and we'll come back to that here in just a second. Up top, you have your command manager. Your command manager is your groups of commands that we're going to cruise through and use during the course of this presentation. And the command manager, in a lot of cases, I worked tech support for many, many years in SolidWorks tech support. And a common phone call we would get in tech support quite a bit is, hey, my command manager is gone or is moved. So I just clicked it and moved it by accident. And that's kind of interesting, but you can see what this is being called here. It's the command manager, and it's just your group of buttons. So sometimes folks will take this and put it on another screen. You can have your command manager on a separate screen to save space if you want to save some space on your SolidWorks screen. I'm going to put this right back up here at the top so our command manager pops back into the right space. Over on the right side, this is our task pane. In the task pane, you can get to things like your design library, which is, for example, a common folder of assemblies or parts that you might work on. So in this assembly, there's a mold assembly that I work on often, for example, so that maybe that's there. Or maybe you save features there, like every time you create a new part, you like to put your name on it. You can have your name saved as a feature and drag your name onto your part for an example. Or maybe every time you make a part, it always has this same screw mounting point. All of your parts have this same screw mounting point on the top, so you can save that as a feature and drag and drop it in. So that's all pretty good uses for this design library on the side. There's also other functions over here as well. There's a full-on file explorer, so you can look through the files on your machine. There's a home area, and this is an area that I tell people who are new to SolidWorks to go to quite often, because in home you can find things like SolidWorks RX. SolidWorks RX, if you're brand new and you're just getting started with SolidWorks and you install SolidWorks on a new machine, this is a great place to start, because RX, I'll just open up RX here. RX is a tool that basically checks your machine to see if it's okay to run SolidWorks. It will do a diagnostic on it. So if I check diagnostics here, this will check my machine and tell me how good the machine is from a hardware standpoint, and see if it'll be able to run SolidWorks. This will take a minute, so I'll let this kind of chug for a moment. You also have something called the reliability tab in here. The reliability tab, if you're crashing, if you ever see a crash with SolidWorks, you can go to this reliability tab and see your history and actually see when you crashed, and it will give you some insights as to maybe why you crashed or what happened. Is it your graphics card driver? Did you run out of RAM? All of these things can be checked here on the reliability. I'm just waiting for diagnostics to load here, which usually doesn't take this long. So we'll put that over here for the moment. We'll come back to it. So these are all good things to know about, and RX is a tool you want to know about. Another tool in here, Copy Settings Wizard. Being brand new to SolidWorks, when you set up your machine, when you set up SolidWorks, you might have a few settings that you really want to keep or want to remember. So after you set your interface, after you create your settings, this tool here, Home Copy Settings Wizard, this allows you to back up your settings. I'll zoom in here a little bit. This allows you to back up your settings and save them off to a new place. And then later on, you can restore them. If you get a new machine, or if you have to reinstall SolidWorks for some reason, you can restore your settings to a previous time, which is pretty convenient. Okay, so we'll close Copy Settings Wizard, and then in the meantime, my diagnostics have loaded here. So diagnostics will tell you things like what's going on with your graphics card and your graphics card driver, which are very critical to SolidWorks. You also see things like how much free space do you have, how much system memory do you have, when was the last time you rebooted. I haven't rebooted in 3 days, which is bad. You should reboot often, more often than that, I guess. But this is just an area, again, where you can get some information. Somebody in the chat earlier mentioned, how do you download SolidWorks? We're actually getting a link here to get out to the downloads page to see the versions of SolidWorks, but you have to log in to see that page, for example. Okay, so that's a brief interface overview just to get us started. And again, we have an assembly open and we're in SolidWorks 2021, and I kind of now know what's going on with my interface. So what we're going to do in this presentation or this example is recreate a part. We want to remodel one of these parts from scratch. So there is this yoke component. There's this central component that really controls the whole movement for the saw. So as the saw goes up and down, it pivots around this central yoke. Shubham's here as well. Hey Shubham, thanks for coming. I'm seeing the chat here as well. Good to see you. Let's get the chat going, folks. Let me know what you think. Let me know what kind of questions you have. Feel free to chat with everybody here in the chat. But this central yoke is basically our control or our pivot for the upper half of the saw. Let's recreate that part. Let's make that part from scratch and then drop it into this assembly and create it. So I think this is pretty interesting. When you click this component, when I click on this face, it highlights that component in the tree, that yoke. It's called yoke saw pivot. I could even, open that part on its own. But what it's trying to show me is that yoke is actually part of, let's zoom in here, it's actually part of this higher level assembly. That yoke is part of this whole subgroup, right? Here's our yoke, but it's actually a member of or a part of head yoke, this higher level sub-assembly or subgroup of parts. So if I pick that whole subgroup and just hit delete on my keyboard, this will delete that assembly from the screen here. I'm not getting my delete window. Oh no, is it hiding somewhere? Let's see. Let's see. Amrit, my delete window is hiding on another screen or something. I gotta find it because it's not popping up for me. Let's see. Delete, delete, delete. Where are you? Let's see if I can do it like this. Head yoke, and then we'll do delete. Oh, my delete box is popping up somewhere else. It's all the way over here. It was it was hiding on my other screen behind GoToMeeting. All right, so we got delete up on screen here. Let me get the chat back up here. And once I hit delete, it's warning me that, yeah, you can delete that, but it's also going to delete some of these other dependent items. Is that okay? So SolidWorks is just checking with us on that. We'll hit yes. We get rid of those items. And I think this is interesting that once you delete that subassembly, we've actually detached the saw. So it's just like real life, right? You have this thing on a workbench, and I remove that part, and now these two groups are no longer connected. There's no gravity, so the upper half of the saw doesn't fall onto the table. But again, it's just like you're in real life, and we've now removed that connection between these two groups. So we need to now recreate that yoke, remake that part from scratch, and bring it in. So SolidWorks is just like any other Windows-based program. When you want to make a new file, we do File, New, up here at the top. And the new window will ask us for a template. And templates are really useful because you can save your settings, save your functions, save controls that you don't want to set up every single time. So for example, I have a group of templates here just every time I make a new part for this saw. Or maybe I'm a saw designer and I work for this saw company, DeWalt or Craftsman or whoever, name your saw company, and I do a lot of saws. So I have a template that's set up specifically the way I like it when I'm creating new saw components. So I'll pick that part and we'll hit OK. This opens up a brand new blank part in the window. There's nothing in the tree. This is an individual part. It's not an assembly. This is an individual part. And I have basically a clean slate to start with. So SolidWorks is very much a 3D program. Everything is in 3D. But so much of that still starts with a 2D sketch. There's still so much 2D sketch to be aware of and to know how to do. So if you have experience with AutoCAD or any 2D sketching tool, all of that is still very useful here in SolidWorks. So let's take a look. If I click on the front plane, for example, I click on this front plane, I get a shortcut here to begin a sketch on that front plane. And right away, it gives me kind of a preview of what that front plane looks like. And now I can begin sketching. So let's just sketch a couple items here. So maybe I will drop a midpoint line. Midpoint line is pretty cool because you can just pick the origin and kind of hover out in space until I see that little yellow indicator pop up next to my cursor. That yellow indicator is an automatic reference from SolidWorks, an automatic relation. So SolidWorks is trying to tell me if I drop this line right here, it will lock it horizontally. It will be a horizontally locked line. So if I select there and just kind of move off, the behavior of that line is it's locked horizontally. I can't move off of the horizontal, but it is still undefined in terms of length. So we'll come back and do that here in just a moment. Anywhere where your mouse is, anywhere basically on screen here, if I hit S, I can get the shortcut window. So shortcut will show you a list of commands that kind of pertains to what you're doing right now. So maybe I have to trim some sketch entities. Maybe I have to sketch some circles or do some slots. This menu is customizable. So you can put whatever you want in this shortcut menu. So anywhere where my mouse is on screen, I get a nice little S key shortcut that I can use. So for example, if I want to grab this circle command, I can do one circle here and then one circle here on the side of that line. And because I dropped them right on those points, they are now completely locked to that line. So they're now dependent upon the length of that line. I really like this tool, this as well, that if I pick two items, I pick a circle and then I hold control. That's a Windows function, right? If you want to pick two items in Windows, you hold control and pick two items. You get a list of relations or a list of rules you can apply to those items in conjunction. So for example, let's make them co-radial, let's make them tangent, let's make them concentric, let's make them equal, which is probably what I'm going to do, or we can fix them where they are, make their curves equal length, or auto insert dimensions on both of them at the same time, which is also pretty cool. I'm going to do this one. Let's make them equal. So now I've created a new rule here, a new equal radius rule that says however big one gets, the other one will follow. And actually at this point, neither one of them are the leader. They just follow each other. Whatever one does, the other one will subsequently do as well. Okay, so that looks pretty good so far. And now let's put a box around these. So I'm gonna you can either come up here to your command manager, or again, you can just hit S and find your center point rectangle, which again, as an AutoCAD user, I used AutoCAD for years. This was something I would have loved to have then. Maybe they have it now, I don't know, but I haven't used it in a while. But you click the center and then you just drag your box out and click the second half of your box. And just like that, you have a very nicely created box that's tied to that center point for you automatically, which is pretty cool. Okay, so that's our rough profile for what I want to do in this sketch, but we definitely need to lock this down, because so far all I've really been doing is sketching, and it's really just that. You don't have to worry about dimensions, you don't have to worry about overall size quite yet. You're just sketching on screen. So let's start to lock this down with some dimensions. If I pick this edge, for example, I can see that when I sketch that edge, it was roughly 250 millimeters. And that's just how I sketched it on screen. But I know that I need to start locking this down with some actual dimensions. So if I hit S and I grab the dimension tool, Smart Dimension, which is like our one trick, single tool for doing any dimension you might want to do on your part. So I do a dimension. If I pick this edge, there's that 250 roughly, how I sketched it. That's just the rough dimension. And if I drop that on screen, and I know I actually wanted this to be 120 millimeters, so I just type 120 and hit enter. This is interesting what happens right here when I hit enter. It actually, in that single moment, scaled down all of my sketch entities with that first dimension. That's why it's powerful in SolidWorks that you don't have to really worry about your dimensions or your sizes while you're sketching that first sketch. Just get it close, just get it proportionally correct for something that works for you. And now when I go to lock everything else down, they're all pretty close. They're all not too far off of what I know I want them to be. So if this one should be 80 millimeters, for example, and then I know, actually I think this is 40. We'll make this 40 millimeters. And I know these interior circles should be 30. So all I have to do is dimension one of them. I'll dimension one of these circles at 30, and then the other one will follow because they have an equal relation. And then I'll just dimension the distance between those two circles at 80. And just like that, I see my sketch turn black. So the sketch for us means that it is, a black sketch means it's fully defined. I can't actually apply any more rules to it. It's completely locked down. And that's a good practice in SolidWorks. When you're sketching in SolidWorks, you want to fully define every time. You want to lock down your sketch as much as possible all the time. There's one more small change before we take this sketch and make it into 3D. Is this line I used as mostly just a location point for these two circles. I want that line to just be referenced. So if I simply click that line, there's a function here to make that line construction geometry. So when I click that line, I'll just do construction geometry, and then it kind of gets this dashed appearance telling us it's just there for construction. Okay, so I'll pause there for a moment and just kind of check the chat. Is there any questions about sketching? Any questions so far? I see Shubham still in the chat. Thanks, Shubham. Appreciate that. Okay, no questions so far. If you have any questions, let us know. You can drop those in the chat over there. So this is interesting. At this point, we're still just 2D. This is like an infinitely thin piece of paper, right? And we've only been sketching in 2D, but SolidWorks is certainly all about 3D. So if I take this sketch and I travel up here to Features, Extruded Boss will take a 2D sketch and turn it into a 3D model. So I see what my profile looks like here, and it's intelligent that it even knows to exclude those circles from my extrusion. So as I extrude this, I can just click and drag this, by the way. As I extrude this, it's automatically excluding that circle shape from the middle. So this saves me a step. I don't have to go back and cut this afterwards. It's already removing that material for me right out of the gate here. So I actually want to do this. Instead of just this one direction, I want to do mid-plane for a total of 60 millimeters. And you can define this over here. You can define how far you want this extrusion to go. And maybe it's up to another surface. Maybe it's based upon an equation. You can actually put simple equations in this field as well. If you can basically treat this field like an Excel field, like an Excel cell. You can write simple equations or write functions in here. It's actually really, really powerful. But for now, we'll just say this is 60 millimeters and we'll hit green check. Why is my boss hidden? Let's see. There we go. So I'm getting a nice image now of that first shape. And obviously we did that very slowly. We took our time and made that sketch. But it's all based upon that 2D profile. And that's something I try to remind people when they're just getting started with SolidWorks. Here we're doing SolidWorks for beginners. You know, don't be afraid of a 3D model, or don't be worried about designing it, because so much of it is still based upon a 2D sketch or 2D profiles. Okay, this looks pretty good. And I agree with Shubham in the chat here. He's saying that this is a bit tricky when doing extrusions at offsets. I agree. Like if I wanted to do another extrusion here on this top face, and I'm just going to go off on a tangent here, and I just sketch a circle. I'm not going to fully define it. I'm sorry. I'm not going to do it this time. We'll just leave it underdefined. Don't tell anybody. And I'll extrude this at some distance here. You can also choose, instead of extruding from the sketch plane, do it at an offset. So offset this by 5 millimeters or something, and then it will begin the extrusion 5 millimeters off of that face. That's powerful, because in the future, that creates a very intelligent relationship between, I'll hit green check here, that creates an intelligent relationship between this face and that face underneath, that no matter what, they will always have that 5mm air gap, that 5mm gap between those faces. Really, no matter how tall this part gets, we can extrude this to the moon if we want to. You'll always have that 5mm gap on that face under there. And the same goes for this face. If this face were to move, if this face were to go down, that other feature will then update as well. That other feature will maintain that 5mm gap, which is pretty powerful stuff. All right, now that I've totally screwed up my model, I'm gonna go back here and fix this. Okay, Control Z, undo is your friend. Control Z, let's hear it in the chat. Does everybody love Control Z? Because I certainly do. I use it all the time. Not even just in SolidWorks, I use it everywhere. Where's my delete box again? I'm trying to just get rid of this guy. There we go. Okay. So the feature I really want to create is the ears on the side of our yoke here, the ears that will ultimately hold the rails, ultimately hook on these rails and grab these posts here on the saw. So we need to model some sort of ear or some sort of shape that would do that, right? That would pop up and grab those sides. So I'm going to begin sketching on this face. Vesant says, yeah, he loves Control Z as well. Thank you. I appreciate that. That's awesome. In SolidWorks, you can sketch on any flat face. So I began this model on the front plane, sketching on the front plane, but you can also sketch on any flat face. So if I pick this flat face here, I'm going to turn off Instant 3D. If I pick this flat face, I have the ability to sketch on it. And that's actually a nice sanity check in SolidWorks. If you're not sure if a face is totally flat, that's a great way to check, is pick the face. If you have the ability to sketch on it, it is flat. It is a perfectly flat face. So I'll pick this face here, begin a sketch, Control 8. I'm hitting Control 8, which orients my view, which makes me perfectly lined up with this face. Now we're ready to begin sketching. So I'm going to do a couple functions here. I once again will grab this 3-point corner rectangle in this case, and we're going to click on 1 point, 2 points, and then the third point somewhere up in space here. So now I've created a rectangle that is hooked to these 2 points, but it's infinitely tall. We haven't locked it down in terms of how tall it is right now. And that's really great. So you can sketch and pick up on references of existing 3D geometry. Any existing 3D vertex or edge or face, I can pick up on that while I'm sketching. So let's put a couple more circles up here. I'm going to hit S and grab the circle tool. The circle tool, we want to base that upon the center point, but we don't want to hook the second one down, and you'll see what I'm talking about here in a second. So maybe I'll grab this and drop this point here just as a reference. That's the first one. And then the second one, I'm going to drop like maybe somewhere in the middle of the part, like right there. So I'm just kind of roughly sketching. Again, like we saw before, your sketches don't have to be perfect. You just want to get them close when you're sketching. So now I'll hit S key and get my dimension. And I know my dimensions here pretty well. I know that I want that distance up to the top, up to the saw to be 82. So we'll put an 82 there for our height. I know that this inner diameter, this inner circle should only be 16. It should be pretty small. And then I know this one here should be 60 millimeters, because that 60 should match the overall width, the overall dimension that we extruded our part here. That's 60 millimeters that we drew that part out to. That's the same diameter I want for this upper ear. So if I exit the sketch here, we have a few different options we can choose at this point. We could do what we did before, right? We could do what we did before by picking this sketch, going up to extruded boss, and then inside of this boss tool, I can pick through these contours and decide what contour do I want to extrude. So for example, I could start with this face, which is pretty cool. I could just extrude this out to whatever dimension or whatever depth I want to. Then I could add this one, and then we could cut out the middle material. But there's a faster way. And sometimes in these presentations, like even if you know SolidWorks, if there's anybody on the line here today that already knows SolidWorks pretty well, maybe you'll pick up a tip or two, or even just something you didn't know about today. So one of them that I use quite a bit is this contour select tool. So the contour select tool, you know you're in it only because I see that little utility or that little icon next to my mouse. I can now just pick through these faces. So I should be able to pick through some of the faces here. So like this one, for example, and just drag this out to 20 millimeters, for example. That looks pretty good. Oh, my sketch is hidden. Now I'll pick this guy. I'm still in that contour select tool. I can just push that to 10 millimeters. That's pretty cool. I don't have to go into the boss command. I'm just kind of doing this directly from the contour select tool. And then I can pick this interior, and if I pull this out, it turns into a boss. But if you push it in, it turns into a cut extrude automatically. It auto removes that material on the inside, and then we'll hide this sketch here. So that quickly, right? That quickly we made 3 new features in the tree, a boss extrude, and a cut extrude, just from that one tool. So that's how you can definitely save a little bit of time. Now here's the question, and maybe I'll kind of post this in the chat. This hole, I kind of just dragged that through there, right? I didn't really define it. I didn't put a dimension on that hole. So the one concern with that is, what if you ever come back and recreate this model and you make a giant version of this saw and suddenly that hole isn't able to get all the way through? The hole maybe, you know, bottoms out at some point. So let's get this hole up on screen. You know, if you ever recreated this saw, maybe you run into a scenario where the hole doesn't go all the way through. It bottoms out because that dimension wasn't totally defined. So one of the things you can do with these holes is, if I right click the hole and do edit feature, right click the hole once again, and I choose through all. Through all, instead of a blind hole, through all means no matter how far this body is in depth, no matter how big it is, let's make sure this hole goes all the way through. I'll choose through all, and then look at my mouse right now. It's telling me if I do a right click, it will confirm the command. Right click will confirm the command. So I'll do right click just to confirm. My mouse never left right here. My mouse never left this really small region. So that's one of the things we teach in Beginners for SolidWorks, is when you're just getting started, SolidWorks will usually present you with at least a couple shortcuts to prevent you from having to travel all the way across the screen to find a command. So that one was right click, edit feature, right click again. You can edit the feature right from here. So if I changed it up to next, up to a certain surface, and then there's even a green check in this list, or my mouse was a green check, the right click on my mouse. So I try to teach that to new SolidWorks users is keep your mouse in one region and go a little slower, but in going slower, you sometimes end up going faster because you find shortcuts and you find faster ways to do things. Okay, so that looks pretty good. Pretty happy with this one side here. Now the thing with SolidWorks is it's a parametric modeler, meaning that if you create an item on one side of the part, we should be able to mirror it to the other side. I shouldn't have to remodel, redo all that on the other side of the part. So very easily, I can find the mirror command up in features, and we'll go to mirror. And then in mirror, you basically just have to pick what is your mirroring plane and what do you want to bring over to the other side. Because of how we modeled this part, the right plane cuts right through the middle of the part. And that is another key thing that we teach to brand new SolidWorks users is, whenever possible, model your parts symmetrically. Position them on the origin so the part is symmetric about those planes. So for me, I'm taking advantage of that right now by picking this right plane, and I'm going to either choose certain features, like I could just bring all of those features we created from one side to the other, or could even just do this option, bodies to mirror. With the body to mirror option, whatever is on one side will be added to the other. It's as simple as that. So if I mirror this entire body side to side, I'm getting a preview. The yellow is a preview of what this body will look like, and I'll hit green check. So now I'm kind of just looking at the tree, right? What have we done so far? I'm gonna maybe drag this guy over here so we can look. So far, we've created this with an initial boss. That our boss was this shape here with the 2 holes, and then we sketched a box around it, right? And we extruded that. That was our first shape. Then we added these 3 very quickly. These 3 features. Wrong button there. We get these three features really quickly, and then the last thing we did was mirror it over to the other side. This is my nice sketching job I'm doing on this model here. But the point is, the tree is keeping track. The tree is keeping a record of your steps for how this part was created. So maybe the final thing we'll do before we bring this over to the assembly is let's round off some of these sharp edges. If we know that if we sent this file to the machinist, they would say there's no way I can machine that part. Too many sharp edges. We gotta knock some of those edges down, especially these inside edges, right? Like, how would you possibly machine that and create that? That would be pretty difficult, right? Maybe we could 3D print it, but not cut it out of metal. So I've got a lot of different ways we could round these edges off, but SolidWorks gives you a really powerful fillet tool. And that's just what SolidWorks calls it. Some people call them rounds, or we actually group chamfers in here as well. So under the fillet tool, you'll find the chamfer tool as well. It's called different things in different software. Here we call it the fillet command. And the fillet command, you can either do a manual or a automatic approach. We'll do the manual method right now, just for the example today. But I really like this, that when you pick an edge to fillet, if I pick this edge and maybe I want this to be a 20mm fillet, I get a nice preview of what that's going to look like. It's going to round that off really nicely. I can get this edge of the part without even having to spin it around. I don't even have to spin the part to be able to pick that. I'm picking it right through all of these faces. So if I pick that backside edge, get a nice preview of how to fillet that, which is cool. And then I'll hit green check to confirm that fillet command. So I didn't have to do, if you're a new SolidWorks user, I didn't have to do a cut extrude to round that off. The fillet command is powerful enough to handle that for you and basically remove that material for you. Let's do some more fillets. So now I'll go back into fillet and we'll change this down to maybe a 2mm fillet. If I pick this edge here, if I pick this one edge, SolidWorks will give you a menu of similar edges on the part. So I can kind of hover over these items and see if any of these groups work for me. And it just saves you time. It just saves you time having to pick all those edges. And sure enough, this group, this connected edges, all I had to do was pick one edge and it found 9 other connected edges to apply that fillet to very easily. So we'll hit green check. So just like that, I was able to fillet and round off all of those interior edges. And finally, if I do the fillet command one more time, there's another option in here. I'll zoom in just so we can kind of see it here, called tangent propagation. Tangent propagation means that when I pick one edge, it will propagate around the part to any edge that is tangent to that one. And that tangency depended upon our sketch. When we created those sketches, when we created those relations, that's where it's picking up on those tangent relations. We'll hit green check. So that's our rough model so far. I'm going to save this. I'm going to hit save, and I'll just drop this maybe in my downloads folder for today. We'll just call this yoke, and we'll just give this a name. What's today? The 14th, 5/14. Any questions? Just checking the chat here. Shoebum's agreeing that the mirror command is really powerful, and I agree that seeing somebody make big use of the mirror function is like, oh wow, that is really powerful stuff. And I think the other thing to realize about it is the tree that we're creating here is chronological, meaning that when when we kind of take a look at what's going on, only the things before the mirror are mirrored. You know, only the things that happen before the mirror are the items that are mirrored. Things that happen afterwards are not. So when you're creating your part, you can think about that I only want to mirror certain functions, and I can use the mirror command when I'm ready. And you can even use it more than once. You can do it again if you want to mirror another group of parts over to or features to the other side of the model. But it's chronological. The tree, we can actually roll this back. The tree is like a time machine. You can go back in time and see how this part was created, one feature at a time. So I'm just kind of rolling forward here to see what happened. And it's also useful if you get a part from somebody else to do this. Open a part from somebody else, and you can actually see step by step how they created their SolidWorks parts. Okay, so what does it look like to take this and drop it into the assembly? So we'll jump back to the assembly here. I want to take this part we just created and drop it in here and see if it fits. That's what 3D modeling is all about. That's what this whole experience is all about, is seeing it, if this will fit before physically creating this in 3D. So I'm going to go to assembly and we'll do insert components. Insert components will show you a list of any part you have open. So we opened that fence earlier, that's still open, and then we'll also click on our yoke. And once I click on the yoke, it shows me a nice preview of where I can drop this. And I'm just going to kind of drop it in space here to get started. And I like to think about this again like a workbench. Like I've just added this to the workbench. It's not yet attached to anything. I can move it around, I can rotate it. I haven't yet attached it to anything else, but it's there. It's there in physical space. And I now see it's now the newest part of my tree. It's now the newest and last part in the assembly, seeing it in order, seeing the list of parts that were added there. So how do we add it to these parts? How do we attach it? Parts in SolidWorks are held together with mates. That's the term we use. In fact, I can see this list here. I'll just zoom in so we can kind of take a look at the list of mates that are here. This is the existing list of rules that hold all these parts together. And again, you're seeing this term up here, this mates folder. And that mate is the rule, or is the connection from one part to another in SolidWorks. So let's create a mate between this cylindrical face and this cylindrical face up here. So if I pick that face, hold Control, and pick that face, SolidWorks again will see those two faces and understand that they have a commonality, or maybe in this case they're two cylindrical entities. So holding Control, pick that face and that face. I see a menu here, just like we saw in the sketch. A menu saying you can make them parallel, perpendicular, tangent, concentric, which probably works for us. And then there's some other advanced mating functions that probably don't pertain to these two parts. So let's pick this one. Let's pick concentric. And also notice SolidWorks is highlighting that one. It's kind of putting a box around that one, saying this is probably the one you want to use for these two faces. I'll attach those two faces. I'm going to zoom in so we can see what happened. I've created a rule that says that cylindrical face and that cylindrical face have to remain on the same axis now. We've basically taken the axis that runs through their centers and aligned them with this rule. I can still rotate, I can still translate, but they have to remain aligned on those two axes. Let's do the same thing for the other side. So I'll pick this face, hold Control, and pick this face. And in this same menu, I'm getting concentric again. This is a good sanity check for me. This is a good point, because if these two shafts were not the exact same dimension as those two holes, SolidWorks would not let you apply this second mate, this concentric mate. So if I apply that one and then we'll hit green check, if that dimension between those two holes from shaft to shaft is not the same exact as our dimension from here to here, that mate would not work. So a good question in the chat: what are the industry standards for designing in SolidWorks? So I mean, there's definitely a lot of standards in SolidWorks. Maybe that question probably has a lot of different aspects to it, but for example, if I open up our units here, our document settings, you can decide in this standard whether you're designing to ANSI or ISO or DIN standard, or you have different standards to set your preferences to. I think I'm just currently in ANSI right now, but I think the industry standard also depends on what you're creating, what you're modeling. If you're modeling medical parts, if you're modeling saws, if you're creating plastic toys, you know, there's probably different standards for all of those design realms in SolidWorks. I hope that answers the question. Okay, so we've applied 2 mates to this yoke so far, and that's fitting on there pretty well. And then the last one we'll do is just this face and this face here, and we'll make those. We could do a couple different things. I'm going to make them coincident, which means make sure that those 2 faces share the same plane. We could probably do, you know, an offset as well, maybe set a distance of 0 and have them be at 0. But in this case, we'll just do coincident and line those 2 faces up. So now our new yoke, I can't move it. I can't move it at all. It's now completely locked onto the saw, and it's now completely mated in place. So the second part of this is getting the rest of the saw attached to our new yoke. And there's a couple different ways we could do that. We could follow our same path as before, picking this face, holding control, and picking this face and applying a mate. But there's other ways you can do this as well, that if I just click this face and start dragging it, and I tap Alt on my keyboard, Alt will start looking for faces to mate to. Alt is like a automatic mate function. So Alt, because I tapped Alt, that cylindrical face starts looking for other cylindrical faces to snap onto. And in this case, it found this cylindrical face, so I'll hit green check and apply that. And now we can see we have really nice saw motion based upon our new yoke there. So that's a rough look at creating a part from scratch as a SolidWorks beginner, a new person using SolidWorks, dropping it into an assembly to see if it fits. That's the whole idea. Now, if you're an advanced SolidWorks user, or when you really get a lot of experience with SolidWorks, what you might find is you just create the yoke here. You actually create and model the yoke here in the context of this assembly. So there's no question it's going to fit. It's actually based upon, it's actually designed upon this assembly, this structure here. You can certainly do that. And in fact, as you get more advanced and more capable in SolidWorks, that's what a lot of people tend to do. That's the difference between bottom-up modeling, creating the parts individually and putting them together, or top-down modeling, creating the assembly and populating the parts from the assembly down. Both of these approaches will still pay off, though. You know, both of these approaches still get you a lot of advanced functions here in SolidWorks. So like here's one of them. If I move my saw, I might notice that there's collision between the saw and my new yoke, the saw guard here. So one way you can check for that in the assembly is to do interference detection. I want to do interference detection between this part, and I'll hit calculate. It will actually show you how much mass is overlapping, if there's collision or if there's a crash between those 2 components. So that's one of the valuable tools of putting an assembly together, is to check for fitment. So as a SolidWorks user, how do we address that, or how do we deal with that? I can edit this part right here. I can make a change to this part right here in the context of this assembly. If I double click this part, here's all the dimensions that we use to create it, right? Here's every dimension, every sketch dimension that we use to create it, including this 60, this depth of 60. So I'll double check this 60, and we'll change that in this case to 40, and I'll rebuild my part here. And now I see that the yoke updates, it moves that distance back, and I have way more clearance between this guard and that yoke now. And it held on to every other rule. All the fillets recalculated, everything else recalculated and updated. This face is still attached to this face, even though it moved back by 20 millimeters. that's the power of building in those dimensions and creating those rules correctly, is when you make a change, you want your part to update and respond predictably or normally. You want it to be something that makes sense and you can make changes to very easily. Any questions? Maybe I'll just take a pause there. Any questions or comments? So there is a question in the chat about getting the blueprints for this, and I guess we're probably talking about SolidWorks drawings there. And that's another really powerful aspect of SolidWorks, is as soon as you have this model created, and by the way, check that out, right? When I changed the part here, it updated it here. It actually updated back in the individual part file. So SolidWorks is associative in all directions. If you make a change in the part, it will update the assembly. If you make a change in the assembly, it will update the part as well. Let's take this part and make a blueprint. Let's make a drawing of this very quickly. So I'll take this part we made before and I'll do file up here. We can do file, or we can press this button, make drawing from part. We call blueprints, we call them drawings in SolidWorks. So I'll hit drawing. I'm going to just choose a standard template. And the drawing is blank for right now, right? We see the blueprint or the drawing has a name here. It's just calling out the name. You can put your logo in here. You can put your information in here if you want, but for now it's just empty. But SolidWorks will present you with a menu, a palette of existing views. So if I click and drag my front view, then I can project the top view, the right view, and then the isometric view up here on the side. So from a blueprint standpoint, I now have every view or every angle of this model covered with a simple drag and drop, and just kind of dropping them in there. Then how about dimensions? How about the information for how this part was created, right? I can go to annotations, smart dimension once again, and just start smart dimensioning this to tell somebody, yeah, this hole was 30 millimeters. I know that the distance between those two holes from one to the other was 80. You can do that if you want, but we have something called model items. Model items can go back to the model and import everything, import all of the dimensions that were used to create this part. So here's all of our dimensions that we initially created the part with, and it will bring them in. It will actually migrate them here to our blueprint. So that's nice. It looks pretty good. And you know, we're getting a good question in the chat about tolerances. Tolerances is interesting, right? Because when I'm creating this assembly, when you're creating the model and creating the assembly, it's not taking into account any tolerance right now. There is no tolerance. It's a zero tolerance right now when you're creating the assembly, when you're modeling this part. But when I am making the drawing, when we're making that blueprint, and I know that the distance between those holes needs to be 80, but yeah, there's tolerance. There's probably some finite level of tolerance between those holes. I can pick this dimension and apply a tolerance. So right now it's set to none. If you see this screen over here, it's set to none. But I can change this to basically a basic or a bilateral tolerance maybe. And we'll say this is 80 plus or minus, you know, a very small small amount here in millimeters. And we really need this thing to be close, right? If it's going to fit on this saw, we need these holes to be pretty close to tolerance. But my point is, tolerance is something you can easily specify on the drawing or on the blueprint when the model is being created. You can also specify it on these parts. There's something called DIM Expert, where you can put tolerance information on the dimensions that were used to create this part. But the cool thing about that drawing is the dimension will then come back to the model as well. Again, anything you change anywhere in SolidWorks is associative in all directions. So if I add it in the drawing, it will certainly come back to the part as well. Hope that answers the question there on tolerances. And Amrit, maybe I'll pause there. Any questions? What do we think so far?
Actually, I want to convey that the person who is asking about blueprints, he is asking about the blueprints of the whole assembly, so he can make this by himself. That's what he
I
was
can
asking, I think.
sure. I could share this. You know, we could share this yoke. I don't think we could share out the sorry, I don't think we could share out the whole assembly, but there's definitely miter saws out there. You know, if you're looking to download some sample files, you could probably find those. But I mean, this is quite the assembly. There's a lot of parts in here.
Yeah.
Definitely. Any other questions? Just checking the chat here. So there will be no changes in the model, just tolerance information. That's basically correct. Yeah, there's really no changes in the model. The model, again, there's no tolerance. It's completely perfect. I guess you could say that, right? There's really no tolerance, but the information is stored here. So when you manufacture this part, you know the tolerance information for those parts. There is a tool in SolidWorks called Tol Analyst, and Tol Analyst allows you to do tolerance stack up analysis. So when you input all this information, you know, this part has this tolerance and this part has this tolerance, and you stack all that up, this tool can actually analyze how far out the model could possibly be, worst case scenario, if everything was pretty on pretty far end of the tolerance spectrum. That tool can do that. But yeah, really, when I'm adding that, it's not changing the model at all. Okay.
Yeah, absolutely. If okay, one more. I want to try this. That's why I want
To try this, that's why I asked for blueprints. Yeah, so you know what? I mean, another good thing to do in SolidWorks is when you're in here, if you notice in this design library, mold bases, sample mold base, or just in this folder, this assembly is always here. This assembly is with every version of SolidWorks. That's why I just refer to it, because I know it's always going to be there. And you can do the similar things here, right? You could delete this top plate part and then go about recreating something like that. Recreate, you know, sketch on this face, recreate a part based upon those holes. You could do a very, very similar thing, but this part, this assembly is a great assembly to test with, and it's in every version of SolidWorks. Maybe for beginners too, because that question maybe sounds like that person's looking for some samples or looking for some things to get started with. Even if you do the help window here, help, and then we pick tutorials. Tutorials will open up in a separate window from SolidWorks. I'll just kind of shrink this down a little bit. It'll open up in a separate window, but the tutorials are interactive. So if I did, you know, advanced techniques and we did equations or advanced design, it actually walks you through this step-by-step tutorial, and the parts are built in here. So when I click on, let me jump back to like a part here. When I click on this feature, it says click on this boss. It actually takes my mouse and shows me where it is on screen. So these tutorials are interactive to SolidWorks. So if you're looking for basic parts or things to get started with, I would definitely check out those help tutorials. And then there is a whole list of really, really nice tutorials in here to get started with. There's some cool ones in here. Shubham saying, driving dimensions in drawing affects physical models. So does that happen when we give tolerance to? I don't think so, Shubham. So like when I gave that dimension tolerance here, I really believe it's just storing that in the dimension. It's not changing that dimension at all. So if I then jump to the assembly and I click, the tolerance is there. It's listing here in the tolerance window, but I don't think it's actually changing it at all. I think it's just listing it there. Driving dimensions in drawing affects physical models. Yeah, so Shubham, I hope that answers your question, but yeah, I don't think it'll change or affect the model. Cool. Okay, so Amrit, I hope that was a good intro for SolidWorks beginners. You know, I know some of that stuff was probably a review for you, but I hope some of the folks here, I hope you enjoyed it. Let us know in the chat if you want to see more of this kind of stuff, whether it's myself, Amrit, or we get somebody else to come back and do more tutorials. We're more than happy to do that.
Yeah, absolutely. It was great. Like I was working in SolidWorks for since 2 years, but I learned many new things here. Today itself, like that sudden, what should I say, boss extrude thing.
Oh,
That
the
was as
contour
I
select
was,
tool, yeah.
yeah, control selection thing.
Cool. Yeah, the only weird part about that contour select tool is you have to have instant 3D on for it to work right. So when I was in, like if I did the same thing, we just sketch on this face here, sketch, and I'll just do a couple circles, right? Just so I have some contours there. I have, let me get out of the sketch. I have instant 3D turned on. So you want instant 3D turned on when you do right click, contour select, which is where, right here, contour select. Then you can pick through these faces and find like that guy, for example. But that's the key, is making sure you have instant 3D turned on. Cool. Okay, yeah, awesome. Thank you, everybody. I appreciate it. Getting some good feedback in the chat. I appreciate it. And Amrit, I'd love to come back sometime if you'd have me.
Absolutely, I will invite you again when we required your help.
Cool, awesome.
Okay, we can have a group photo together if everyone can turn on their camera.
Group photo, yeah, awesome. Anybody who wants to. I'll stop sharing my screen here. Need some more coffee.
Okay, thank you everyone. Yeah, it's not a problem. Okay, I have some announcement, like something to share. Okay, those who are asking for SolidWorks, like how can they get SolidWorks? So they can get a 2-year student edition key. So for that, what you have to do, you have to mail us on jodhpurswug@gmail.com and at shubhamdatta0551@gmail.com with the following details. So you can take a screenshot of the screen and follow the same. We will provide you the student license key for the same. These are my some social media handles, like you can connect with me on LinkedIn, on meetup. You can mail me or you can call me on the number. Okay, that's all for today's session. Thank you, sir. Thank you, everyone.
Thank you, Amrit. Appreciate it. Thanks, everybody.
Have a good day. Good night, everyone from to Indians.
You as well. Have a good evening.
Yeah.
All right. See you, everybody.
See you.